Hello and good evening, Dr. Chia. I am Jerry Fletcher Anamajang, and this is our presentation for Project 1. Yes. So, for introduction, based on the project given, we are needed to create an E3 value model analysis to identify value exchanges, actors, and economic profitability within the smart city ecosystem, ensuring a sustainable business growth. Yes. So for actors, we have app developer, city council, shopping malls, normal citizens, and elderly citizens. Scenario 1. So our value configuration is EEP. What is EEP? EEP is a regulatory requirements. So the city council mandates support for elderly easy payment, which allowing senior citizens to park at a 50% discount without needing a smartphone. For this system, the app developer needs to get operation license granted by the city council. And then for city council and shopping malls, the app developer must have a settled revenue since the app developer needs operation license from city council and they need a venue which they will implement the system, which is the shopping malls. Yes. So the settled revenue is in the form of formal allocation agreements. So for the system, the standard rate for normal citizens is 1 ringgit per hour, whereas the elderly citizens, which gets a 50% discount, is 50 cents per hour. So this is the profit analysis table. As you can see, there are actors, cost, and total. App developer gets revenue and commissions, which is around 1,403,900 ringgit, and the city council set a revenue originally was 100,000 ringgit per year, but then the city council needs to pay 20,000 ringgit commission payment to app developer. Hence, that's why the settled revenue that city council gets is 80,000. And then the shopping mall settled revenue is what 10,000 ringgit per year, whereas we assume citizens and elderly citizens visits a shopping mall in Kuching around 1 million time per year, whereas the citizen will pay around 1 million ringgit per year, whereas the elderly citizens, we assume that they pay 500,000 a year, which is half of the price where normal citizens are paying. So this is the E3 value model. And for the question asked in the project one question, this is the strategic risk management, whereas developer vulnerability without risk sharing mechanism, the app developer bears the full burden of usage drops. If settled revenue targets are not met, so the developer receives substantially lower commissions, risking a shift into net loss states. Yes. Scenario 2. Scenario 2 is external market shock. It happens with the substitution effect as well, whereas a newly constructed mega mall opens in the proximity to the council zones, implementing a policy-free parking. This creates a severe disruption in the ecosystem transaction volume, whereas the current smart parking system, citizens need to pay their parking per hour, whereas this new mega mall offering free parking for the citizens. Yes. Revenue deficit modeling. This affects a lower customer visits, whereas from estimated value, which we estimate 1 million visits per year, in Kuching to 600,000 visits annually, which also cause annual ecosystem revenue deficit, which is a 40% drop, as you guys can see inside the chart. Yes. So this is the profit analysis table. As we can see, the app developer revenue and commissions are lower than scenario 1, which is in scenario 2, we have 797,900 ringgit, and the city council settled revenue and commission payment are fixed since the drop in for the revenue deficit revenue is not affecting city councils and shopping mall. whereas the citizen and elderly citizen payment are severely dropped to 40%, which is the citizen pays around roughly 600,000 ringgit per year, and elderly citizens pay half of that, which is 300,000 per year. The 40% drop in transaction falls completely on the primary system operator as partner agreements with shopping malls and city council remain fixed. And that is all from me. Thank you.
Hello, good evening. My name is Fernandez, matrix ID 113067, and I'm going to present for the scenario 3 and scenario 4. For the scenario 3, we have data monetization pivot. It's about de-risking the value network through a data as a service model. The strategic shift in business model. The data as a service model to hedge against downside risk from sudden drops in public parking occupancy. The app developer pivots away from traditional transaction commission frameworks with public stakeholder. It's neutralizing council costs, commission and settle revenues between the city council and the app developer are restructured to ringgit Malaysian 0.00. So this eliminates operational fee outlays for the municipality while protecting system continuity. Next is value configuration, B2B advertising loop, anonymize traffic data. The app developer package real-time anonymize consumer movement patterns collected via the smart application infrastructure. Then predictable revenue. Local business and advertisers purchase data access through structured annual subscription, moving dependency away from daily parking spike. Then ecosystem scope. The updated network integrate 15 distinct corporate accounts, paying a yearly subscription to unlock targeted location-based advertising tools. So here we can see 1 million hours for citizen based volume, then also 1 million hours for elderly based volume, and then 6,000 for the annual subscription between the distinct corporate accounts, so 15 of them. And then for the ecosystem profitability breakdown, so the app developer, the value object or cash flow type is the primary revenue and advertising fee, which for the annual total is 1,580,000. Then the city council is for the value object is settle revenue and the commission, which is both zero. And then shopping malls, settle revenue is 10,000. Local business is negative 90,000. And then standard citizen close about 1 million per year, and then elderly citizen lose about 500,000 per year because of the EAP. This is the NPV for the scenario 3, which is 3,929,000 for the 3-year net present value, the NPV. This result in a strongly positive NPV that guarantees a high commercial viability for the app developer while insulating municipal budgets. Then for the scenario 4, which is enforcement failure analysis, which is hardware scanning failures, revenue leaks, and governance mitigations. Technical loophole and the transition leaks. The 15% camera recognition error rate leads to environmental disruption like heavy local rainfall and inadequate street lighting cause a system degradation blocks, resulting in a 15% error leak across the deployed license plate recognition camera array. Then next is the free riding phenomenon. Because the app architecture cannot register unscanned vehicle, a substantial technical cap develops, allowing 15% of parkers to exit without transmitting payment. So the volume adjustment, it become 1 million to 850,000 per hours, as well as the elderly citizen. This structural volume leak reduce gross transaction income generated from public parking areas. Then for the scenario 4, financial impact of the system leakage is for the app developer, the structural cost is net inflows 1,348,000. And then for the city council, it become 80,000. And then the city council also lose 17,000 because of the successfully scanned one. Then shopping mall, same one as scenario 3, 10,000. Local business, also the same one, 90,000. And then the standard citizen and elderly citizen lose about 850,000 for the standard citizen. And then for the elderly citizen, they lose about 425,000. Then the ecosystem reciprocity and the governance control is strain value exchange. The 15% system scanning failures put an immediate strain on the reciprocity. The city council lose potential unlock parking, revenue collection, and the developer incurs direct transaction commission rollbacks. Next is license to operate retention. Despite the leak, the council maintains the operating license. Reverting to manual physical wardens or paper coupon would introduce higher operational overhead and deployment labor costs than absorbing the 15% scan lag. And then this is the robustness and NPV sustainability. For the developer, net annual profit is 1,292,000. Then the council net annual clearing is 63,000. And then for the 3-year net present value NPV is 3,213 ringgit. So the conclusion is the platform remain robust and fundamentally profitable over times, even with hardware scanning limitation. That's all from me. Thank you.
Hello everyone, my name is Cassandra Kalonakupa. My matrix number is 109271 and today I will present scenario 5 of our smart city parking system project, which is called the incentive strategy, or also known as the smart refund mechanism. So in this scenario, the city council introduced a new strategy to reduce traffic congestion and improve parking space utilization. The idea is simple. If a user leave a parking spot at least 15 minutes early, the system gives them a small refund credit. Then the parking spot is immediately updated as available in the app for another user. To support this incentive strategy, we updated the E3 value model by adding two new actors, which is citizen A, represent the user who leave the parking spot early, and citizen B represent the next user who occupies the available parking spot. So these two actors help us model the parking turnover process more accurately. So next, we added several new value exchanges into the system. The first one is the smart refund credit, where citizen A receive a refund incentive for leaving early. The second value exchange is early exit information, which allows the system to detect that the parking spot has been released. So the third value exchange is real-time spot availability. The system immediately informs citizen B that parking space is now available. So the flow of the scenario works like this. First, citizen A park using smart parking system. Then citizen A leave the parking space earlier than expected. The system processes a smart refund credit and update the parking space as available. Next, citizen B receives the parking availability update and occupies the same parking space. This generates a second parking payment transaction within the same operational period. So now let us analyze the value of this strategy. So before the smart refund mechanism, one parking spot could only generate one parking payment transaction per parking cycle. However, after introducing this incentive strategy, the same parking spot can now generate two parking payment transaction from two different users. For example, citizen A pays 1 ringgit as parking payment and then receive 25 cents as smart refund credit. And then citizen B pay another 1 ringgit for the same parking spot. As the result, the total net revenue becomes 1 ringgit and 75 cents instead of 1 ringgit previously. As the result, parking turnover increases, parking space utilization improve, and the app developer receive additional revenue despite providing refund incentive. So this is the profitability analysis. The app developers still maintain positive revenue because the second parking station helps offset the smart refund cost. The city council also benefit because traffic congestion is reduced, parking search time decreases, and smart city traffic management becomes more efficient. Overall, the net present value or NPV remains positive for the major actors in the network. In conclusion, scenario 5 shows the smart refund incentive strategy successfully improve both the operational efficiency and economic sustainability of the smart parking system. That's all from me. Thank you.